Good evening and good morning. Welcome back to Math Agility Live. This is our new platform where students can send in their math homework problems to our social media channels in IG and Facebook and in Twitter, and we will answer them via Facebook Live every Tuesday and Thursday. That is 6 p.m. to 8 p.m. Pacific Standard Time or PST, and it's Wednesday and Friday 9 a.m. to 11 a.m. Manila Time. Tonight, we will be exploring and solving the type of questions in the Singapore math curriculum. I am actually getting some inquiries about Singapore math if we're doing tutoring sessions with this. And the reason I became interested on searching a little, a little bit about the Singapore math. And this is what I found out. Some facts about math curriculum or Singapore math. So, number one, Singapore math has been recognized worldwide to its for its excellence in producing students with highly skilled in mathematics. They're consistent in number one in the trends and international mathematics and science study. So if you can Google it, TIMSS. So Singapore math is always on top and it's always ranked number one. And then another thing that it interested me is that the American Common Core standards was actually adopted from the Singapore math, and you can see there are many references on the strategies and research about Common Core standards on the Singapore math. And actually, Common Core standards, we call this, the goal is actually to prepare American students for success in college and in the global 21st century workforce. So Common Core standards is also have raised the bar for American students, especially in mathematics and science, and strategies taught in Singapore Math Challenge or Singapore Math curriculum will actually help students meet this new expectation. So there's been you call this intersection of or same goal of Common Core standards of the US and Singapore math curriculum in of course in Singapore. So what shall we do today? So we will try to answer some problems. I don't know how many minutes we can do this. Let me share my screen to you. Just give me a second. Okay, let me just okay. I hope you can see my whiteboard, my virtual whiteboard on your screen. So I've gathered some questions from the Singapore Math book. So the first question that we will be answering is this one. So it says, Jeremy is twice as old as Randy now. 6 years ago, the sum of their age was 18. How old is Jeremy now? So this is an age problem. And let's see. So Jeremy is twice as old as Randy. So let's try to make a table out of this. So let's say Randy first and then Jeremy. Okay. My method is actually not the one that is Singapore math is using, but I'm going to use my own method in solving this Singapore math problems. Okay. Just to be clear. So, and then, so now, so let's say Randy is X. That's his age. And it says Jeremy is twice the age of Randy. So 2 times X would be the age of Jeremy, right? So again, so now that is their age now. And then 6 years ago, so if it says 6 years ago, then we should subtract 6 from the age now, right, of each person. So Randy's age would be X minus 6, 6 years ago, right? And then Jeremy's age should be 2X minus 6, 6 years ago. And then the problem says the sum of their age was 18. So 6 years ago, if you add them together, the sum would be 18. So if we add this two together, so the sum of Randy and Jeremy 6 years ago, so x minus 6, and then 2x minus 6 should be equal to 18, right? So the question is, how old is Jeremy? So let's try to solve x first. So if we combine like terms, this would be 3x minus 12 equals 18. So x and 2x will be 3x, and then negative 6 and negative 6 would be negative 12. So let's transpose 12 to the right side of the equation. So a negative number, when we transpose to the right side or the other side of the equation, becomes positive, and a positive number, when we transpose to the other side of the equation, becomes negative. So in this case, we have a negative number. So 12 will become positive when we transpose it, right? So, and then let's add 18 plus 12. So 3x equals 8 plus 2 would be 10. So 30. So divide by 3. So our answer would be 10. So x is 10. But the question is, how old is Jeremy? So Jeremy's age is actually 2 times x. So if we multiply this by 2, 2x, so 2 times 10, so 20, right? 20 years old. So this is the age of Jeremy. Okay? Hope you understand that. If you have any questions, you can write in the comment section of our Facebook page, in Instagram, and then also in Twitter. And okay, so let's move to the next question. So the next question, oops, let me just move this a little bit. So let's read the problem. So it says Caden and Dave had an equal number of cookies. If Caden ate 7 cookies and Dave ate 5 cookies, how many more cookies did Dave have than Caden in the end? So again, we will do the table method. So we have Caden initially having, and what's the other one? Dave, right? So initially they have same number of cookies. So let's say X number of cookies. So then it says there, if Caden ate 7 cookies, so after, right? So this was before. So if Caden ate 7 cookies, so we should subtract 7 from X, right? So X minus 7. And then Dave ate 5 cookies, so we should subtract X minus 5 in Daven's case. And so, and the problem says, how many more cookies did Dave have than Caden in the end? So how much more cookies did Dave have and Caden in the end? So we need to subtract X, Dave minus Caden. So Dave, just erase this. So let's say Dave X minus 5, and then we have Caden as X minus 7. Let's move this a little bit. So subtracting this, of course, X would cancel out, right? And negative would become positive. So negative 5 plus 7 is 2, right? So meaning 2, uh, Dave has 2 more cookies, right? Than than Caden in the end, right? Okay, so 2 more cookies. Dave versus Caden. right? Did you get this? So again, if you have any questions, you can type in at the comment section, and we will I will try to answer them later after this live session with you. Okay, so let's do number three, third question. Okay, so it says here Roy had five times as much money as Shane. Roy spent $54 and Shane had twice as much as Roy in the end. How much Roy did have at first? So again, let's do the table method. So let me write Shane, and then we have Roy. So it says that Roy had five times as much as money as Shane. So if Shane has X money, so this is now before, sorry, this was before, and next is Roy has five times as Shane, so this will be 5X. And then after that, Roy spent $54. Okay, so after, so if Roy spent $54, we need to subtract 54 from his original money, right? Originally, he has 5x of money, and then when he spent 54, so we subtracted 54 from 5x. And then it says there, when Roy spent 54, Shane had twice as much as Roy in the end. So Shane actually doesn't change, right? His money, but Roy's money was decreased by 54. So this is still X, but then it says this become twice of this, right? So X, which is Shane money, would be twice of Roy in the end. So this is after the fact that he spent $54, so 50x, 5x minus 54. Okay, so let's solve this equation. So x equals 2 times 5, 10x, and then 2 minus 54, 2 times 54 is 108. Okay, let's move things here. So this would become 10x minus x. Let's move 108 to the left. So I would have 9x and 108 here. Let's divide both sides by 9. And we will have x equals $12, right? So what's the question again here? So how much Roy did have at first? So Roy had actually at first 5 times x. So and we solve x as 12. So 5 times $12 would be $60. So this is Roy had at first. Okay. All right. Okay, let's move to the fourth question. Okay. Let's move to number 4. Okay, so number 4 is, okay, let's read the problem. Ami had 25% as many marbles as Ben. After Ben gave some of his marbles to Ami, Ami now has 37 as many marbles as Ben. What fraction of the marbles that he had at first did Ben give to Amy? So, of course, again, let's do the table method. Okay, hold on. So if we say this is Ben and Amy here, so Ben is X initially, right? And Amy had 25% of Ben, so 25% of X. Okay, and then after um, Ben gave some of his marbles. So the only thing I would do here is to represent another variable. So I would subtract y from uh Ben's initial number of marbles, which is x, and then what happens is 0.25x. So this y moves to Amy's number of marbles because Ben gave it to Amy. And it says there after she gave it, or after Ben gave it to Amy, Amy now has 37 as many marbles as Ben. So this one here would be equal or equate to 3/7 of x minus y. So 0.25 x, sorry, there's an x here. So x plus y is now 3/7 of x minus y, right? So let's try um, to solve this. So 0.25x plus y equals 3/7 of x minus 3/7 of y. Oh, sorry, y. So let's transpose y to the left-hand side and all the x on the right-hand side. So this becomes y plus 3/7 of y equals 3/7 of x minus 0.25 of x. So this means this is 7 over 7 here, right? So this is 10 over 7y. This is 3/7x minus 1. 0.25 is actually 1 over 4 of x. So let's try 10y over 7. So if you add this two together, this would be 28. 28 divided by 7 is 4 times 3 is 12x minus 7x. So this is, oops, 5 over 28, right? 5x over 28, 10y over 7. So y is equal to 35 over 280x, or 7 over 56x, or y is equal to 1/8 of x. So meaning Ben actually gave 1/8 of what he had initially. So he had x, right? Let's go back to the problem. He had x initially, Ben had x, and our y is actually the number of marbles he gave to Amy. So, and that's 1/8. So initially we can say that Ben had 8 units, right? Originally. And if he had 8, then he gave 1 unit to Amy because 1/8 of 8 is 1, right? Okay, so let's move to the next problem, which is problem number 5. Okay. So if you have any questions, you can type in at the comment section. I will try to answer them after this live session. Okay, let's do number 5. So it says here there were 60 cookies in a box. The number of raisin cookies was 1/3 the number of plain cookies. Okay. Chantel ate an equal number of raisin and plain cookies. Find the difference between the number of raisin and plain cookies in the end. Okay, so again, I would write the table method. So first is we have, oops, so raisin and plain cookies. So plain cookies is x number of cookies, and it says there Raisin is one third of the plain cookie, so one third of X, right? And so after what's the Chantal ate same number of raisin and plain cookies, right? So we should deduct an amount of Y. Let's say Y is the number of cookies she ate from raisins and the plain cookies, and it says they are equal in number, right? Okay, it says at the first sentence that the total cookies in the box are all 60. So if you try to add one third X plus X, you should have the value of 60, a total of 60. So one third X plus X equals 60. So this means this is 3 over 3. So 4 over 3, right? X equals 60. So X would become 15 times 4 is 45. Yeah, 45 cookies. So there are 45 plain cookies and 15 raisin cookies, right? Because the total should be 60. So raisin is 15. Okay. And then it says after, so if we say 145 is the plain cookies. So if we say this is 45 minus y, and the one third x is 15 minus y, uh, we are being asked the difference between the number of raisin and plain cookies. So let's try to get the difference of these two. So 45 minus y minus 15 minus y. So 30. So y negative y plus y would be 0. So the difference of the number of cookies would be 30. Number of cookies. So these are all the difference of the cookies between raisins and the plain cookies after uh, who's this girl? Chantal, right? Eight each of those cookies at the end. She would have a difference of 30. Okay, let's go to the next question. Okay, what number is this? Number 6. Okay, so number 6. So Ryan had $120 more than Caden. Caden had one fourth of as much money as Ryan. Both of them spent a total of $170 on some gifts for their friends. As a result, Caden had two-thirds as much money as Ryan. So we will be solving A, how much do they have altogether in the end? And then B, how much did Caden have in the end? Okay, altogether and then Caden. So again, let's do the table method. So if Ryan is and Caden, right? So this is 120 plus X because 120 more than Caden and Caden has X. And then the next sentence says this X, Caden has one fourth as much money as Ryan. So one fourth of X. So meaning, let's take the difference of these two. And whatever we get should be the difference of money they have, right? So 120 plus x minus x is equal to x minus 1/4 x. So this would be 120. This would be 4 over 4. So 3/4 of x. So x should be, so 4 times 120 divided by 3 is $160. So Kaden had 160 initially. So, and then what's that? 1/4 x. So 1/4 of 160 is 40, right? So x and 1/4 of x divided 1/4 is 40. Okay. So the total money should be 200, right? So 160 plus $40. So total, and then it says there they altogether they spent a total of 170. So if we subtract 170 here, what is left is $30 altogether. So that's for letter A. So letter A is the money they had altogether in the end. And then let's solve for K then. So for K then, that is, we have at the end it becomes 2/3, right? At the end, this becomes 2/3 x. So meaning 2/3 plus 3 over 3, right? So 2, oops, is equal the money they had altogether. So x, this is what is left, right? Who's that again? Sorry. So after they spent $170, a result, Kaden had 2/3. So this is what is left to Kaden, and Ryan has X, of course. And if we add them together, it should be equal to 30 because this is the money left for both of them, right? And we already solved that is 30. So if we add x plus 2/3 x equals 30, it's just this one. So this is 3 over 3 plus 2 over 3. So 5/3 x equals 30. So this would be x is 90 over 5, or it's 90 over 5. 18. So $18. So K then had 2/3 of 18. 18 divided by 6 is 3. So $12, right? So at the end, Kaden would have $12 only. All right. Okay, let's move to the next problem. So this is problem number 7. Okay, so let's read. Lisa had 20 more apples than Joanne, and then Lisa gave Joanne 3 apples. How many more apples did Lisa have than Joanne in the end? So, okay, let's do our method. the table method. So Lisa, Han, Joanne. So it's not writing. So Joanne has X, and this is 20 plus X, right? And then after, it says Lisa gave 3 apples to Joanne. So we should subtract 3 here, and then we add to Joanne's number of apples. So, and then the question is, how many more apples did Lisa have than Joanne in the end? So we'll try to simplify this. This would be 17 plus X. Of course, this is still 3 plus X, or X plus 3. And if we try to subtract, because we're looking for the difference between Lisa's number of apples to Joanne, so minus 3 plus X. So X cancels out, and 17 minus 3 is 14. So 14 apples. So Lisa had 14 more apples than Joanne in the end. Okay. So this is the number of apples Lisa had at the end. Okay. Oops. So let's move to number 44. Number not number 44, but number 8. Question number 8. Okay. So the question is, there are 75 students in classes A and B altogether. There are 61 students in classes A and C altogether. The ratio of the number of students in class B to class C is 5 over 3. How many students there are there in class A? So, okay, we will use our own method. So if we add A plus B, the sum would be 75, right? This, so A plus B, 75. And then there are 61 students in classes A and C. So try to read the second sentence. A plus C is 61. And then there's a ratio of the number of students in class B to class C. So ratio of the number of students in class B to class C. So we can represent a ratio by this. So B is to C is equal to 5 over 3. Right? So we have 3 equations, 3 unknowns. I know this is a little bit difficult compared to the Singapore math. It's I think it's more easier. The Singapore math method is more easier to use when solving this kind of problem. So what we're trying to do here is, if we can solve with other methods, which we can compare with the Singapore math method. Okay, so if we say B is 5/3 of C, right? I just cross multiply C, and then let's try to substitute this to the first equation. So A plus 5/3 C is equal 75, right? So I just plugged in the value of B, this one in the box, to equation number 1. And I have this equation here. Now I want to eliminate A because I have another equation here, which is, which is A plus C equals 61. So by elimination of A, so let's try to subtract A plus C equals 61. So A cancels out, and then 5 thirds C minus C is 75. So 14, right? 75 minus 61 is 14. So this becomes 5 thirds C minus 3 over 3C is 14. So this would be 2 thirds C equals 14. So C should be 14 times 14 divided by 2 is 7 times 3 is 21. So in class, the number of students in class C is total of 21. So but the question I think is A. Yeah, so how many students are there in class A? So since we already know C, we can solve A, right? So basically A plus C says is equal to 61. Since we know C, we can solve A. So 61 minus C. 61 minus 21 is 40. So there are 40 students in class A. 40 students in class A. All right. So do you have any questions? So if you have, you can write down in the comment section of our Facebook page and Instagram and Twitter at Math Agility. Okay. Okay, let's move to the next problem, which is problem number 9. Okay, the length of a rectangle is 250% its width. Given the perimeter of the rectangle is 280 centimeters, find the width of the rectangle. So it's easier to understand if we can draw it first. So let's draw the rectangle. So if we say our width is x, so our length, it says is 250%. So that's 2.5 of x. So we change the percentage to a decimal, which is 2.5, right? So it says here, given the perimeter of the rectangle is 280 centimeters, we know that the perimeter formula for a rectangle is 2 length plus 2 width. It's basically the sum of all the sides of the rectangle. So twice the length, so 1, 2, and twice the width, which is 1, 2. So twice the length plus twice the width. Since we know that this is equivalent to 280, we can equate it. So 280, 2 times 2.5x. Let's substitute this, our values, and then 2x. So our answer here should be 280 equals 5x, right? Plus 2x. So this would be 7x to 80. Let's try to divide them by 7. And x is what? 40, right? So the width of this rectangle is 40 centimeter. So don't forget the unit. This is the width of the rectangle. Okay. That's a pretty easy question, actually. So let's move to question number 10. So Willie bought 15 pears and Jack bought 18 oranges. They spent the same amount of money. The difference in cost between a pear and an orange was $0.10 or 10 cents. How much did Willie spend on the 15 pears? So again, let's draw the table. So if Willie has bought 15 pairs, right? And Jack bought 18 oranges, and they spent the same amount of money. So X and X spent. So so X, if we divide X by 15, so that's the cost of one orange, right? One pair. Cost of one pair. And then X over 18 is the cost of one orange. All right. And it says there, if we get the difference of a cost of one pear and one orange, that is 0.10. So 1 x over 15 minus x over 18 should be equal to 0.10. So x over 15, which is the cost of one pear, minus the cost of orange, this is x over 18, is equal to 0.1 or 0.10. Okay. So now we're ready to solve the equation, and we can find the value of x. And how much did we spend on the 15 pairs? Okay, so we're trying to solve for x here. So let's try to combine first this. So this is the greatest common factor would be 90. So this would be 6x minus 5x equals 9. 90 times 0.10 times 0.1 would be 9. So x equals 9. So $9 is the amount that Willie spent on the 15 pairs. So this is the amount of money Willie spent on number of the number of pairs. All right. Okay, let's move to the next problem. So number 11. So let's read the problem. Caden and Dave had an equal number of game cards at first. Caden bought another 20 game cards and Dave bought another 47 game cards. How many more game cards did Dave have than Caden in the end? So let's again do the table method. So Caden, oops, let's try to use another color. So and Caden and Dave. Okay. So Caden initially and Dave, they have equal number of cards. So let's say they have X initially, and then after Caden had bought 20, so this would increase by 20 plus, and then Dave bought 47, so this would increase to 47. And then the question is, how many more game cards did Dave have on Caden? So we will subtract Dave minus Caden's. So X plus 47 minus X plus 20. So this is 0. So we have 27. So the difference of cards would be 27. So Caden Dave or Caden have more cards. Yeah, so Dave had more, 27 more cards than Aiden. Okay. All right. If you have any questions, you can write it down at our comment section in our Facebook, in our Instagram, and Twitter accounts. Okay. Okay. So let's move to number 12. So problem number 12. Okay. So the question is Kelvin gave 2/7 of his money to James. As a result, Kevin had 140 and James had 100 in the end. How much did James have at first? So, okay, so let's use the table method. So, Kelvin, not Kelvin, Kelvin and James. So, let's say Kelvin had X amount of money originally and James had Y money. So, before. And then, um, 2/7 of his money, Kelvin's 2/7 of his money he gave to James. So we should subtract 27x from this, and then we add 27x to James' money, right? After. So this is before. Okay, and after it's this equation. And then it says there, as a result, Kelvin had 140. So this should equate to 140 and James had 100. So this should equate to 100. So let's first solve x from the first equation from Kelvin's money. So x minus 2/7 of x equals 140. So this should be 7/7 here. So this would be 5/7x equals 140. So x is $196. So we can now solve for y. Y plus 2/7 of 196 equals 100. So what is 2/7 of 196? So 196 times 2 divide by 7. So that is 56. So 100 minus 56, we have 44, right? So 44, I think, is the question being asked. So how much money did James have at first? So Y is the number of, so this is James money at first. Okay, $44 to be exact. Okay, so let's move to the next question. So number 13, right? So 13. So the average of three two-digit numbers is 61. One of the numbers is 33. And what is the largest difference between the other two numbers? So, okay, so we have three two-digit number and the average is 61. So sum, we can say that the sum of the three two-digit number is 61 times 3, right? Because the average is 61. So 61 times 3 is 183. Okay, next is it says there one of the numbers is 33. So if we subtract 183 minus 33, so we have 150. This will be the sum of the other two-digit number of the two-digit numbers. Sum of the two two-digit number. Right? So if we're having two digits number, so the highest number we can think of from 150 is 99, right? We cannot have 100 because that's three digit. The highest two-digit number is 99. So this is the highest two-digit number from 150, right? From the sum. So if 99 is the highest number, so 150 minus 99, we have 51, right? So 51 is the smallest number, right? So smallest number from the two, from 99 and 51. So what's the question? What is the largest difference? So what is the largest difference, yes, between the two numbers? So if we subtract 99 minus 51, that is 48. So this would be the largest difference between the two numbers. Okay, I hope you understand this problem. Okay, so let's move to number 14. Question number 14. How many questions do we have here? Actually? So we have, okay, we have one, two, three, four. Four more problems, okay? Okay, so the figure on the right is drawn using straight lines only. Find the value of the sum of angle M, angle N, angle O, angle P, and angle Q. So, so this is a bit of geometry. So if we look at, okay, let me just change red ink. So let's start first with this triangle here. So this triangle, right? So this includes M, angle M, angle O. So we don't know this. What we do know is that the sum of the angles inside a triangle is 180. So we know that this question mark there is 180 minus M minus angle O, right? So this angle here is angle M and angle O. And we see that this angle here is what? Supplementary to the question mark we have. So we know that this would be where angle M plus angle O, right? Because if we subtract 180 minus 180 angle M minus angle O, if we subtract this from 180, we will have M plus O, angle M plus angle O, which is exactly this, right? Okay, we solved already this part of the angle. Now let's solve another angle. So similar technique, we can get we can get actually this part. So this, so we can get this part here. So this is angle, what is angle N and angle Q here. So we know that this is 180 minus angle Q and minus angle N, right? And if you look here, this is again a supplementary angle, right? So this would become N or Q, angle Q plus angle N, right? So now we combined all the angles inside one triangle. So P, so let me just change again the color of, so this orange triangle here. So this would be your P, angle P. This would be your angle Q plus angle N. And this would be your angle M plus angle N. So we know again that the sum of the angles inside a triangle is 180. So if we add them together, angle M plus angle N, angle P plus angle Q plus angle N is equal to 180 degrees, right? Is it O? This is O, sorry, not N. O, angle O, this is O. This is Q and N. So angle O, M and O plus P plus Q plus N is 180 degrees. All right. Again, if you have any questions, you can write down at the comment section of our Facebook page, of our Instagram and Twitter accounts. Okay, so let's move to the next problem. Okay, this is question number 15. Okay, so the question is, a muffin costs $150 and a tart costs $1. Alice bought two more tarts than muffins. Okay, she spent a total of $14.50 on the muffins and tarts. How many muffins and tarts in total did Alice buy? So, okay, we use again the table method. So let's write muffin and tart. Okay, so muffin costs, so it costs 1.5 or $150, and then the tart cost $1. And then Alice bought two more tarts. So she bought X plus 2 compared to muffin of only uh, X number. And then she spent a total of $14.50. So the total cost of muffin is 1.50 times X, right? Because this is the number of muffins she bought times the cost of each muffin, which is 150. Then we just multiply it together, okay? And then for the tart, same thing, $1 times the number of tart she bought, which is X plus 2. So this is the total amount of the tart she bought. And then if we combine the total amount for muffin and tart, it says here that is equivalent to $14.50. So let's try to do that. So 1.50x plus 1, so x plus 2 equals 14.50, right? So I reduced it just to 1 because it's will be always equal to 1. So let's distribute, let's combine like terms. So 1.50 plus x, so this would be 2.50x, and then plus 2 is 14.50. And then let's transpose 2 to the right side. So again, this is positive. If you move it, it will become negative. So 2.550x equals 14.50 minus 2. So 12.50, 2.50x. And let's divide 2.50 on both sides. X should be equal to 5, right? So this is the number of muffin. Yeah, so this is the number of muffins she bought. And x plus 2. So 5 plus 2, 7. This is the number of tarts she bought, right? And the question is what? How many muffins and tarts? So we just add x. 5 plus 7 is 12. Total of muffins and tarts. Okay. So let's go to number 16. Okay, I think we have two more. So 16, 8, 17, 18. Okay. So let's go to the next problem. So 2/5 of the fruit that Sue bought were oranges, and the rest were apples. Each apple cost point 50 cents, and each orange cost 10 cents more. Okay, 10 cents more. Sue spent 1.80 less on all the oranges than all the apples. How many fruit did Sue buy together? Okay, 2/5. So let's try to. Okay, let's do the. So oranges, 2/5 x, right? And then apples would be what? So if it's 5 minus x minus 2, 2/5 x would be 3/5 of x, right? Okay, what's next? And then each apple cost 0.50 cents. So this is the cost number. And orange is each orange cost $0.10 more. So meaning 50 cents plus 0.10 should be 60 cents, right? So orange is more expensive than apple by 10 cents, right? So that's what it meant. And then Sue spent $180 less on all the oranges than all the apples. How many fruit did Sue buy altogether? So if we multiply this, so 2/5 x is the cost, right? A total cost, sorry, times 0.6, and then 3/5 of x times 0.5. It says there, so this is the total cost. It says there Sue spent 180 less on oranges than all the apples. So if this is the amount, so 2/5 x times zero point 0.6 equals 3/5 x 0.5 minus 1.8, right? Because this is the amount she spent on oranges, and it's less than all the apples that she spent, which is 3/5 x of zero point 0.5. Okay, so now we can solve the number of fruits she bought, total number of fruits, which is x, right? So let's try to use, so 2 times zero point 0.6 divided by 5 So this is 0.24x, and then 3 times zero point 0.5 divided by 5, so 0.3x minus 1.8. So 0.24x minus 0.3x equals negative 1.8. So we have negative 0.06 x, zero point 0.8 divided by negative 0.06, negative 0.06, or x, 1.8 divided by 0.06. So 30 in all the fruits. All right, so let's move to number 17. Okay, so the question is, an ice cream cone costs $160 each. Each customer is entitled to buy another two at a discount of point or 30 cents off the original price each after buying three. Okay, after buying three, each customer is entitled to buy another two at a discount of one offering. So after buying three, find the maximum number of ice cream cones Owen can buy with $24 and the amount of money he will have in the end after buying the ice cream cones. So um, we can group this. So one is costing 1.6. We don't know how many 1.6 ice cream did she buy, so that is X. And then she can get another two for the price, for a discounted price of 30 cents. So 1.6 minus zero point 0.3. So 1.3. So 1.3 times 2, right? So because she can buy two after at a cost of 30 cents discounted. So that's 2.3, 2.3x, right? So okay, so and then the total amount is 24. So we can say this is 24. So let's try to do the math. So 1.3, 1.6 plus 2.3. So this is 3.9x. 24x is 6.1. So we can say she can buy 6 of the 1.6, and then 12 of 2.3 plus 12 of 2.3, right? Because two each one would, she could buy two more at the cost, at the discounted cost. So this is equal to 1.6 times 6 plus 12 times 2.3. Okay, this is 37.2. So mm, let's say she can buy only 5, and this would mean this is 10, right? Of 2.3, because this is over what she had. She only had $24, right? Let's see. Yes, $24. So 1.6 times 5, that's 8, plus 23, that is 1.6 times 5. What am I? Oh, this should be 1.3. Sorry. So 1.6 times 6 plus 12 times 1.3. This is 25.2. So we're still over. So let's try. There should be 1.3, sorry. So 13 plus 8. So 13 plus 8 is 21. So we can still one more of 1.6. So that is 22.6. And she can buy two more of 1.3. But let's see. This is 9. This is 23.9. So she can buy 6 of the 1.6 and 11 of 1.3. So 6 of $1.6, 11 of $1.3. Right? Okay. And she will only have, I think the question is how many is at the end. So 24 minus 23.9, right? Oh, hold on. 24 minus 22.6 minus 1.3. So 22.6, 1.6 times 6, 9.6 plus 13. So 22.6. So 23.9. So around 10 cents, right? What is left on her money left? Okay, let's move to number. I think this is our last number that we will be answering tonight. So let's read the problem. So there are 12 pupils stood in a straight row at equal distance apart from each other. If the distance from the first to the last was 66 meters, what was the distance between the one pupil and the next? So we have 12 pupils. So let's try to draw it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's say 11. 11, 12, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 students or 12 pupils. And then the total from end to end is 66 meters, right? What was the distance between one pupil and the next? So if we will try to get each of this, so this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are only 11 gaps, right? So if we divide 66 meters by 11 gaps, so that would be 6 meter per gap. Yep, that's that. Okay, that's already the answer. So 6 meters per gap. All right, so that's the end of it. If you have any questions, you can again send it via our Facebook uh, page and also on our Instagram and our Twitter account. So there you go. And next Tuesday, we will have another special guest. We will be solving mechanics or strength of materials problem next week. So for college students who are taking engineering courses, so this might be of help to you. So tune in next week. And that's it. So if you have any questions to all our followers who sent in their questions from Thursday to Sunday, which is Friday to Monday in Manila, we will be solving them via Facebook Live next Tuesday, PST, Wednesday in Manila. So see you next week. God bless everyone and stay safe.